Good afternoon. Today we will study what is BNF and syntax diagram. So first of all, we should know that what is the grammar of a language. Every programming language is written by using any syntax or standard rules or procedure. We can say that these standard rules or syntax makes the grammar of a language. Now this grammar can be expressed by two methods, either by using the syntax diagram or by using the BNF notation. So first we will study what is a BNF notation. It is also used to describe the syntax of a programming language, and Backus-Naur forms introduced by John Backus and Peter Naur in 1960s. So before we proceed, we need to understand some terminology that are associated with the BNF. Tokenization. So what is tokenization? Basically, it is a process of breaking down a sequence of characters into smaller meaningful units called token. Let me show you with the help of the example. Now see, let's understand. This is a code written in Python. Now you can see that in this code, we have written x equals to 5, y equals to x plus 10, and then print state. Now, every single unit over here is treated as lexeme, right? This x is a separate unit. This is called the lexeme. Equals to is also called lexeme. Now 5 and similarly y equals to x. These all are called the lexeme. Now, every lexeme belongs to a specific category. That category is basically known as the tokens. So we can say that tokens are basically the sequence of characters. Now, let's suppose this x and y. Both of these belongs to the category of the identifier. So x and y both are lexeme, and which category they belong to? They belongs to the category of identifier. So this identifier is basically the token. Similarly, there are two assignment operator over here. So this operator equals to operator here is a lexeme, and the category they belongs to is the token. The token is here the operator, the assignment operator. So similarly, you can see the rest of the lexeme and the token in this example, right? Now we will study what are the three basic components of the BNF. So whenever you write the grammar of the BNF, so you should know the basic components of the BNF. The basic components of the BNF are terminals, non-terminal, and production rules. So let me show you with the help of example. Now see, whenever you have to write any BNF notation, you have to follow this sequence. There will be two sides of the statement. One will be the left-hand side and other will be the right-hand side. The left-hand side is always the non-terminal symbol. Okay, and then you have to write down this symbol, and we call it by using is defined by. And on the right-hand side, we have terminals, and we can also have the non-terminals. So what is terminal and what is non-terminal? So let's see the definition. Terminals are basically the symbols in the grammar that cannot be further decomposed, like a, b, 1, 2, plus, minus, multiplication symbol. We are not going to further decompose. We are not going to expand them further, right? These are called the terminal symbol. And the non-terminal symbols are basically expandable. For example, I can write digit or letter, and then further I can explain what are the digits. Like digits can be 0 till 100, or digits can be 0 till 4, or digit can be 0 till 9, right? And similarly, letter I can define, maybe I can write capital letter, or maybe I can define the small letter in that definition. So I'm basically expanding the definition of these meta tags, right? These angle bracket, whatever it is written inside this angle bracket, we can call it the meta variable. Because what is metadata? Metadata is the data about data. It is defining the another data. So similarly, when I say that digit can be 0 till 9, so I'm redefining or expanding the definition of digits, right? So let's suppose, and okay, then third one is that there are the production rules in BNF that you have to follow. What is the production rule? This whole notation makes the rule of BNF, that you should have a left hand side, then is defined by, and right hand side. Okay, so this is basically the production rule. Now BNF notation. There are four basic notation of BNF. Okay, so in my definition, I'm going to define the variable is defined by a letter or a digit, right? So further, I'm expanding the definition of this letter over here. So this is non-terminal, and these both are also non-terminal over here. And this symbol is defining that my variable can be a letter like A, capital A, or it can be digit 1, right? So again, now here I am defining my digits. What could be my digit? My digits are limited to 3 digits, 1, 2, or 3. I cannot write 4, 5, or 6, right? So one of the example could be, for example, I can write A and a digit 1. Okay, so this is my definition of the variable. Or I can write B, or I can write 2. Okay, so if I write C and 4, so will it be accepted or not? No. Why? Because in my digit I have not defined 4 over here, so I can only choose either 1, 2, or 3. Okay, now next see the next question. Define a variable that must start with the letter. Okay, I, J, or K, that is followed by up to 3 digits after the letter. The first will be always letter. Okay, so here one letter, one digit, one letter, and it can have 2 digits, and then one letter and up to 3 digits, right? So we can write either letter, only one letter I, okay, then one letter and one digit, one letter and 2 digits, and one letter and 3 digits. I hope it is clear. Now let's go to the next example. Define an assignment statement that can be used for addition or subtraction. So here I will write the word assignment on my left hand side. An assignment is defined by what we have to write? We have to write a variable, and then we have to define that variable in the same statement, because we don't have any expanded of a form of the assignment. So we can write the definition of a variable after this define symbol. So variable is equals to variable operator variable. Okay. The assignment statement basically here is limited to addition or subtraction of two variables, right? So if I get this statement, variable, operator variables, and like I said, it can be for addition or subtraction. So in my example, if I write C equals to A plus B, it will be correct. Okay, and if I write C equals to A minus B, this will also be accepted. But if I write C equals to A plus B plus D, then it will not be accepted, because according to the assignment definition, I'm going to define only two variables, and within two variables, only one operator can occur. Okay. Now let's see how we can represent a single digit. Now single digit, suppose we have a definition here, how the integer is represented. An integer is basically defined by a digit or integer digit. Okay, now let's see how we can represent an integer with a single digit. Now integer is defined by a single digit. Okay, there is no other or symbol over here, because we are just representing one single digit over here. Now further we have expanded the definition of digit. So how many digits I can have? I can have these digits. Okay, so we can write digit is defined by 1 or 2 or 3 and so on up till 0. Okay, so these are different combination, you can say different digits that I can use in my integer definition. Okay, now what is the problem over here? By using this definition, I can only represent single digit. Okay, suppose I want to represent 12. So this definition will not allow me to define 12, because I'm only capable of using single digit, either 1 or 2 or 3 and so on. Okay, so what can I do to represent 2 digits, or you can say 3 digits or 4 digits, okay, and so on? So for that we can use the concept of recursion. Recursion, basically, if you want to represent any number of digits, then you will be using recursion concept. Now what is recursion? Basically recursion, if you remember, recursion is the function that calls itself, right? It is a little bit different concept than repetition. It's not repeating. Basically the function is calling itself again and again until a specific condition is reached. Okay, so now see, let's take an example of the integer 1, 2, 3, 4, 5, right? How it is going to start. So first, if we follow this rule, what is the rule? That integer is defined by digit integer. Now whenever you are writing anything in recursion, always remember you have to, because you are calling the function itself, so you have to repeat the name of this non-terminal on the right hand side as well. Okay, so suppose in previous example we were just writing digit over here, single digit. Now because we want to use the concept of recursion, so we will write the name of this integer over here again. Now what it is doing, it is calling this function again and again. So when it will again call itself, so the definition will be again digit and integer. So first this digit is here. Now when it is called, what will be here? Digit, this digit over here, and then this integer over here. So it is going to repeat itself again and again. Okay, until the last digit or the final definition of a final symbol we is written. Okay, so we start with the first digit 1. Okay, so how many digits are remaining here? 2, 3, 4 and 5. Okay, now 2, 3, 4, 5 is not a single digit, so we repeat the process. Start with the second digit 2. Okay, now 2 is treated here as digit. Okay, and the rest 3, 4, 5 will be called again by the definition of an integer, because it's recursion occurring here. It will call again the recursion. Okay, then you can follow the next three digits 3, 4 and 5. Now 3, 4, 5 is not a single digit, so we can repeat the process. We will start with the first digit 3, and rest we are remain with 45. Okay, now see, 45 is also not a single digit, so 4, we will repeat the process. Start with the 4, it is taken as the first digit and then followed by the remaining 5 digits. Now when we reach the 5, 5 is left out. Okay, there is no other digit after 5, so we can say 5 is single digit here. Okay, so we stop recursion here. Now see, according to this definition, you can see here, whenever we define recursion, first we write here the single digit and the or symbol. This is must. Why? Because we have to stop the recursion. Okay, thus recursion will only stop when we will when we have only single digit left. So if we have left with or the digit with integer, so it is calling the recursion over here. Okay, so we can stop over here. The condition can be met. Why? Because if we are left with a single digit. Okay, or when we have not single digit, so this condition will be met. Okay, now see, BNF notation can be used for recursive definition, where an item defined can refer itself. For example, a variable consisting of any number of letters, or if you will see the term like this, any number of or one or more letters, right? So variable is defined as letter, single letter, or more than one letter, or any number of letters. Okay, you can have, so why this condition is here? Because you want to stop the recursion also. Okay, at some stage you have to stop the your activity. So for example, I'm writing C equals to A, B and D. So first it will take this A as a single letter. Okay, and then it will take B and D, right? Then again it will take B. It will say, okay, this is not a single letter, it has two letters over here, B and D. So next it will take B as a single letter, and then it will reach over D. When it will reach on D, it will say, okay, now I don't have any other letter to be followed. So this condition is met over here. The last one is a letter, only letter is left, right? So let's see another example. Write the definition for integer that consist of any number of digits. So when we get this term, any number of digits, it means you have to apply the recursion. So what we have to define? Integer. So integer will be here. It is defined by any number of digits. So first we have to write this condition before or digit, only digit. Okay, and to apply the recursion, I told you that what we have to do, we have to use this word again, integer over here, because it's calling itself over here again and again. Okay, and then we have to write this word digit over here in the angle bracket. Okay, now see, you can either write 3 or 3 4, or you can write single digit 4, or it can be 4 5 6, any combination. Okay, now let's see a question from our past paper. there are some symbols and letters given. We can only use these symbol and these letters, right? Like complete the BNF for the syntax diagram shown. Okay, we're not going in the syntax diagram right now. For that, so that's why I have written just the symbols and letter that you have to follow. Okay, so how we can complete this BNF notation. So symbol is defined as, and then we have to complete. So how many combination of symbol we have? We have these combinations. Okay, so we can write is dollar, then or sign, and then all these sign along with with or sign. Next is that you have to define a letter, and letter is defined by all these possibilities. So because we have different possibilities, so we can write all this possibility over here by writing this or sign with it. Okay.